Section 5.1, Rates of Change and Slope. A rate of change is a ratio that compares the change in the dependent variable to the change in the independent variable. To calculate rate of change, you take the change in the dependent variable over the change in the independent variable. Generally speaking, our dependent variable is y, our independent variable is x, and so it's the change in those values. So keep in mind that rate of change is often associated with the idea of slope, and when we look at slope in a few slides, we're going to be doing the same thing. Calculating rate of change is very similar to calculating slope. But for slope, we're told that it's the change in our y values graphically over the change in our x values, or more commonly known as rise over run when you're graphing on a coordinate plane. All right, so let's look at our first rate of change problem. The table shows the distance a band marches over time. Is the rate of change constant? So this is what we're trying to figure out. Is the rate of change constant? Let's go ahead and identify our independent and dependent variables. So in this problem, our independent variable should be time, while our dependent variable will be distance. And so to determine whether or not the rate of change is constant, we need to calculate the rate of change at certain intervals. So from 1 second to 2 seconds, or 1 minute to 2 minutes, we have a change in distance from 260 to 520. So as our independent changes by +1, the dependent changes by plus 260. So that rate of change can be calculated by taking your dependent variable change over your independent variable change. So in this case, that's going to be 260 over 1. So the rate of change there is just 260. And then we move on to the next one. So we've got adding of 1 from 2 to 3, and we're adding again 260 from 520 to 780. So because the numbers are the same, I'm going to get the same rate of change. And then I check my last set. 3 to 4 is +1, 780 to 1040 plus 260. So for each interval, we got the same rate of change. So yes, the rate of change is constant. So in the next problem, the table shows the balance of a bank account on different days of the month. Find the rate of change during each time interval and determine if it is constant. So in this problem, our dependent variable would be the balance, or the money, and the independent variable will be days. All right, so let's find the rate of change between the intervals. So firstly, our independent variable change is from 1 to 6, so they're adding 5. So 5 underneath whatever our dependent variable change is, so 550 to 285 is a change of 265. And that's subtracting 265, so we'll put minus 265 there. And so when we calculate our rate of change for the first interval, we get negative 53. So they're losing $53 per day on average. And then we'll go to the next interval. From 6 to 16, they're adding 10. And then from 285 to 210, we are subtracting 75. So for this interval, we're looking at taking negative 75 over 10, which gives us a rate of change of minus 7.5. So they're losing $7.5 per day. These two values are not the same, so this is not constant. So here we're talking about the slope of a line. Remember, rise means the change in your y values between 2 points. Run is the change in your x values between 2 points. And so therefore the slope is, as we talked about in the first part of the video, rise over run, or your change in your y's over your change in your x values. One of the easiest ways to determine slope is to count between the 2 points when you have it when it's done graphically. So for this problem, let's start by looking at these 2 points, and we're going to count the change between them. And remember, slope is going to be rise over run for this. So let's start by figuring out our vertical change. So to go from the leftmost point to the rightmost point, I have to go up 1, 2, 3, 4. So that's 4. and then I have to go right 1. So that's 4 over 1. So my slope is just 4. In the second example, I'll start with the leftmost point and work my way to the rightmost point. And so in this case, to calculate your slope, you're going to start with the rise. So we have to actually go down in this case. So that's -1. And we have to go over 1, 2, 3, 4, 5. So that's 5. So that means our rise is -1 and our run is 5. So we get a slope of -1/5. In the third example, we'll do the same thing. We'll start with the left point and we'll work our way to the right point. So to go from this point, we have to go down 1, 2, 3, 4. So down 4, and then right 1, 2. So that gives us a slope of -4 over 2, which simplifies to -2. Here we're introduced to the idea of the slope formula, so that way when we're given coordinates, we can calculate the slope algebraically. And so this is important, so make sure you highlight this, star this. And so the slope formula is y2 minus y1 over x2 minus x1 when you're given two sets of ordered pairs that are x and y. So let's try the first example down here. I'm going to let -1 be my x1, 0 be my y1, 3 be my x2, and -2 be my y2. And I want to plug these values into my slope formula. And so when I plug in these values, I've got y2 is -2 minus y1, which is 0, over x2 minus x1. Well, in this case, the top's pretty easy. -2 minus 0 is -2. But on the bottom, I've got 3 minus a -1, which is like adding 1, so we get 4 on the bottom. So our slope ends up being a -1/2 when we simplify. All right, we're going to try these two examples as well. So for the first one, we've got x1, y1, x2, y2. And we want to plug these into the slope formula. So y2 minus y1, so 1 minus 5, over x2 minus x1, which is 8 minus 2. So 1 minus 5 is -4, 8 minus 2 is 6, and so when we simplify this, we're going to get -2/3 as our slope. Go ahead and try the third one on your own, pause the video, and then unpause it when you're ready to check your answers. So we'll let 5 be x1, -7 be y1, 6 be x2, and -4 be y2. And so we set up our slope formula. And in this case, we're going to take -4 minus a -7 over 6 minus 5. Well, -4 minus a -7, well, remember, minus a negative is like adding the opposite. So that ends up being a +3. And then 6 minus 5 is 1. So your slope here is just 3. So, as shown in the previous examples, slope can be positive, negative, 0, or undefined. You can tell which of these is the case by looking at a graph of a line, and you do not need to calculate the slope to tell. So if you have a graph in this case where it is going from left to right, the line appears to be increasing or going up, that is a positive slope. If you're looking from left to right and your line is going down, that is a negative slope. If your line stays constant or flat, this is a horizontal line and it has a 0 slope. And if your line is straight up and down, that is a vertical line and it has an undefined slope.